So right over here, we have our PIR motion sensor. And this sensor basically just detects if there is motion in the environment or not. And then we have it connected to my Arduino microcontroller, which is then connected to my laptop for the program. So if you take a closer look at the sensor, you can see that there are 3 pins. We start off with the black pin, which is ground. Then we have the white digital output pin, which is there to give us a digital output of either detecting motion or no motion. There's 2 states. And then we have the red power pin, the 5 volts pin. And so let's actually just dive straight into how this program works, and let's see how it detects the motion. So right here you can see our serial monitor, and it's telling us that there's no motion being detected currently. If I move my hand forward, you can see it starts to tell us that motion is being detected. I'm moving it around, moving it up and down, side to side, and it's starting to detect motion. Now, if I just keep my hand there steady, I don't move it, at the start it starts to detect motion, but then later on, it's just no motion detected. So you can see that it has to actually detect movement. So, now let's actually move on to the video. Hi everyone, and welcome back to Knowledge on Ears. And today, we will be going over a new sensor called the HC-SR501 Passive Infrared Motion Sensor. So what does the sensor even do? Well, it's able to detect if there is motion in its environment. It's pretty simple, and it's like a motion detecting sensor. So you can use a sensor like this in stuff like your home security systems, alarm systems, and other things. And so if you look closely, there's like this dome around the sensor, and this dome actually allows the sensor to have like a larger field of view to detect more motion. So in this case, it's around like a 100 to 120 degree field of view. And that's actually pretty large, it's pretty big. And on top of that, this sensor can actually detect motion over 7 meters away. So that's pretty far. It's actually very, very cool for such a small sensor. So how does the sensor even work? Let's dive into the details. So over here, there are 3 pins, and these 3 pins are for ground, for 5 volts for power, and for the digital output pin. So there's 3. And so we know ground is ground. We know 5 volts gives us the power for the sensor. And in this case, the whole voltage range can be between 5 volts to 12 volts. So there's a huge voltage range. It becomes easier for us and easier to use. And then we also have the digital output pin, which actually provides us with a digital output. So in this case, it doesn't tell us how much motion has been detected, the intensity of the motion. It just tells us if motion has been detected or no motion has been detected at all. So now let's actually get into how the motion is even detected in the first place. So in the past, we have gone over what infrared radiation is. We know that it's a type of radiation on the electromagnetic spectrum, and really, the infrared radiation is just another word for heat. Basically, any heated body emits infrared radiation. So my hand would emit infrared radiation, a living human body would emit infrared radiation, stars and microwaves and ovens, they all emit infrared radiation, and it's pretty simple. So inside of this dome, there is a very special crystal called a pyroelectric crystal. And the special thing about those crystals is that when it detects a change in infrared radiation in its environment, it actually generates a temporary voltage. But the very, very important thing to remember is that we are talking about a change in infrared radiation. Not if it detects infrared radiation, but only if there is a change in the current amount or the current position of the infrared radiation. So basically, how is a pyroelectric crystal, something that detects changes in infrared radiation, able to detect motion? What do they even have to do with each other? Well, let's take a look at this diagram. So right here we have the dome. This is the dome. And we have the pyroelectric crystal divided into 2 spots, half 1 and half 2. And basically, this dome is very special. It's called a Fresnel lens, and it's not there only for the 120 degree field of view. It's actually there for one more reason. It's a very special optical lens, and what it does is that it focuses infrared radiation from different areas onto one of these 2 different sections. So some spots focuses onto half 1, some spots focuses onto number 2. So it creates like this alternating infrared radiation zones, and it just depends where the infrared radiation is coming from. But based on where it's coming from, it gets focused to either 1 or 2. So that's the basics of what's happening. But what actually happens, how are we able to detect motion? Well, let's just say that my hand is here, and we know my hand actually emits infrared radiation because it's a heated object. It's a heated body. So what happens now is that it's emitting infrared radiation. Some of the light goes to 1, some of it goes to 2. But since my hand isn't moving at all, equal amounts of infrared radiation are being received by both 1 and 2. So equal amounts are being received, which means in the end, there's no motion. That's what's happening. The difference between the amount of radiation both 1 and 2 are receiving is 0. And so that's how the system works. If the difference between 1 and 2 is 0, then we know that there is no motion. There's no motion at all. But now let's say my hand is moving quickly. Once it's moving quickly, we already know that the Fresnel lens only allows certain parts of infrared radiation to go to 1 or 2. So if it's moving quickly, let's just say right now, at this moment when it's moving, all of the infrared radiation here is going to half 1. But now once it's here, it's going to 2, and then 1 and 2 again. So it's switching, and that's creating a difference between the amount of infrared radiation in both 1 and 2. And that in the end is making a difference of some amount of voltage that's being generated by the pyroelectric crystal. And so if there is a difference in the voltage generated by the pyroelectric crystal from both halves 1 and 2, then this crystal knows that there is motion. But if there is no difference generated, if the difference is 0, if my hand isn't moving at all, then we know there's no motion. So that's why this pyroelectric crystal only senses differences. It only senses changes in infrared radiation. Even though my hand here shows that there is infrared radiation and it's not moving, that still means that there is no change in infrared radiation, which means the pyroelectric crystal doesn't detect that and it doesn't create a voltage. So that's basically how it works. It's pretty cool, and I hope this made sense what I was saying. But in the end, if motion is detected and my hand is moving, it produces a high signal, and it sends the high signal. The digital output, the pin, gives us a digital output of high. But if it's not moving, then it gives us a digital output of 0. So if it's not moving, it's 0. If it is moving, then it's 5 volts. It's high signal. So yeah, thank you for listening. I hope you enjoyed. Bye!